Well, let's hope that we are live. Right, guys. Who do we have in? Steve Finneran, nice to see you. Squirrel Sniper, hello. Wow. Well, what have we got today? Well, we've got a breakdown of the stuff from yesterday, essentially. How's the presentation? Yeah, I've managed to figure that out now. It's all good. Nice to see you, Stefan. Fuck choose, hello. The Adam Meakin. So Spurs Chemo and the Adam Meakin. You guys both have a link if you want to jump in at any time. Hop on in and we can talk about this. But wow, sensational stuff from yesterday, I have to say. Sleeping Warrior, I hope there is sensationalist music, Ranty, Superman or something. Maybe in the future, who knows, when I put it all together. But basically, this is just a quick breakdown of a couple of videos of a bigger selection of videos that I took throughout the day. So good evening, Chris. Nice to see you in as well. So essentially, this is going to be a warts and all discussion about what actually went down yesterday, the failures and the successes. So it's you know, it was a learning curve. I'll say that for sure. Nice to see you in Ute. Rude Earther, hello. Cosmic Surfer, Chris UK. Don't think I've missed anybody. Oh, Rob McKenzie, 4 Stolarport. Good to see all you guys in as well. So big thumbs up to Rude Earther. Big thumbs up. Rude Earther was the guy that we went down to meet yesterday. He's the one that helped participate in this observation and test, and he's the guy that put his hand in his pocket to the tune of 250 quid to actually hire the boat for the afternoon. So massive thanks to him. And essentially, he just wants the truth. So, and he's willing to pay for that. So, and I was happy to go along and help in that endeavour. And let's just say we've got some sensational flat Earth proof. That's all I can say. Nice to see you, Noel, and Triathlon King. Good evening. Nice to see you as well. Right. Let's see. I better share my screen. Hopefully, it's going to work this time. There we go. All good stuff. Look at that. Oh, the job. Right. Okay. 40 people in. Not too bad. I'm sure we'll have more by the end. However, just make sure that the screen share is working. Yes, it is. Absolutely brilliant. Right. I'm going to hide my share button. And first of all, let's get the warts and all out of the way first. Because essentially in this domain sort of thing, this flat Earth versus globe Earth, there doesn't seem to be a lot of transparency. You know, I'm a little bit different, where I try to tell everybody everything that I can think of to make things a little bit easier going forward. You learn from your mistakes, you hold your hands up from mistakes, and you learn from that. And that way, if you tell people, hopefully when they do a test or an observation, then they won't fall into the same pitfalls. So where to start? Right. Okay. So the weather. Okay. Let's start with the weather. It was a little bit chilly, I have to say, a little bit chilly. The light wasn't very good, funnily enough. It was forecast for pretty good sunshine with a little bit of cloud. It turned out that it was quite a lot of cloud with just very intermittent bursts of sunlight, not very much. However, when the sunlight did appear, everything seemed to show up an awful lot better. So I would say that if you're ever going to do these observations over long distances, especially over water, and you're trying to do some kind of test going forward, you really need to plan it around a really bright sunny day. The wind, unfortunately, again, I mean, the wind was relatively strong for when you're trying to use a P1000. So the P1000, because it extends such a long way, you know, you're talking it's going out at least probably 18 inches or so. So it's got a lot of area where the wind can catch it. So in an ideal situation, you would prefer no wind at all. But once you get past about 8 miles an hour in wind, that's when you start to see wobbling taking effect on your long distance stuff. So the further you zoom in, the longer your camera gets, the more area there is for the wind to actually hit it. So even though the wind was like 11 or 12 miles an hour yesterday, relatively light, cold, but you know, still it was still enough to give a bit of shaking to the camera. So I think if you're going to ever do any of these tests going forward, perhaps bring a windbreak with you if you do go when it's windy. Something that I've would also like to talk about is the perspective from the boat. So we had Rude Earther on the boat, and obviously he's trying to film back with the P1000, and because of the chop of the boat, it was really difficult to actually focus on anything at land. So, you know, he could see the buildings, then he couldn't see the buildings. It was up, down, shaking around all the time. So it was really difficult for the person from the boat. And I didn't think of that prior to actually doing this. I didn't actually think, what would it be like for the person on the boat to film back? Because I just had it in my head that I'll be nice and stationary on the sand, filming over to them, and they'll be able to use their P1000 and film back and film me, and we can compare. I didn't take into consideration the swell and how difficult it would be to get any kind of focus or anything like that. So essentially, that was my bad, poor planning. I didn't think of that. Right. I'll just see who else is in. Let's see who else is in, shall we? Few more shout outs. Sean Becker, nice to see you in. Sandra, nice to see you in as well. Rob McKenzie. Let's see. Okay, Rude Earther, I'm just putting the videos on my PC, but they're quite terrible. Well, it's not surprising. The chop was pretty bad, I have to say, for you guys anyway, at least.
Evening, Randy.
Oh, right. Good evening, Adam. How are you doing?
Not bad, fella. Not bad. Right. I was waiting to join, just listening to the intro, because we only chewed some detail. So, yeah, I'll shut up and I'll leave you to it, pal.
Okay, then. Okay, no worries. If you feel like you want to jump in at any point, fire on in.
You sound like me, mate. I'm a bit shy like that. I'm probably not likely to, but if forced, I will.
Okay, so the people that came along, we had Spurs Chemo. He came down. So he was with me on the shoreline, and we had Rude Earther and a couple of his friends. One of them was a surveyor who went on the boat themselves. We were supposed to be having another photographer there, Sleeping Warrior, but due to his temperament on the day, and he didn't really feel like coming down and helping out, I was pretty much left to just try and do all the observations on my own, because unfortunately Spurs didn't have much experience using the P900 or a P1000. So even though we had 2 cameras ready to go, 2 tripods, we only had 1 set of eyes and 1 set of arms. So it was really difficult to actually find the boat once I'd lost track of it, which only took a couple of minutes really, because essentially due to our individual perspective, the guys on the boat and myself, we kind of were talking at odds as to where they actually were. So it was really difficult, and I'm going to blame the captain for that, because the captain should have done what we asked him to do and he didn't. But that's just the way it goes. Let me just show you what I mean by all this, because it sounds like I'm rambling, but this is where the observation took place, and I've got a few lines set out. I'll show you guys how it actually went down in a minute. But essentially, here's where I was down here with Spurs Chemo. So we were right here, and Rude Earther with the fishing boat. They left from down here, down the channel, and they actually left here, and then I actually got line of sight to them around about here. So let's just put a line in for that so that you can see. Right, so there's my line of sight. So I see these guys when they leave, and I'll show you the video in a moment. Let's just move that over there a sec. So I'm seeing them from my perspective. So there's Llandudno, and so from my perspective, looking over there, they've only left this estuary perhaps a mile or so, and already from my perspective, they've passed Llandudno, right? And then a little while later, maybe another 2 or 3 minutes later, I've seen them pass through these wind turbines from my perspective. So when I was talking to them on the phone, they said to me, "No, guy, what are you on about? No, no." Because when I was seeing them here and I say, "You've just passed through those turbines," they said, "No, no, we're not anywhere there." Because from their perspective, they hadn't even reached the turbines yet. Because this is their perspective. They're heading out in this direction. They're looking directly left. In their perspective, they hadn't even passed Llandudno. They hadn't even passed the turbines. So they were saying, "No, no, we haven't passed these, and we haven't passed that." And I'm saying, "Oh, right, so maybe I'm focusing on the wrong boat." So then what I had to do, so then I refocused, and I spent about 10 minutes looking for these guys in this area. And then they said to me, "Oh, we're just coming up to the wind turbines." Well, I'd given the captain the GPS coordinates for this turbine here, right down here, because I wanted to do some testing around this location. So when they said they were coming up to the turbines, I thought they meant this turbines. However, where they were coming up, they were actually at these turbines over here. This is the turbines they were approaching. So completely at odds with each other. And it was all to do with the captain, because the captain essentially just got in the boat and, you know, he just put his foot down. He was off. And this is the direction that these guys went. So they just went in a straight line right out to this location here. And then they panned across here and they did a little bit of fishing around here. And obviously we had Rude Earther on the boat with a P1000 trying to see me. But trying to find these guys once I'd lost track of them in this location down here was really difficult with just one camera, because I'm trying to look through all these wind turbines. So I had all these wind turbines as blockage. So, and they were a long way away. I mean, these guys had a small boat. The boat was only like 12 feet from top to bottom. And at this point, they're like 13.5 miles away. So really small boat on really long way away through these turbines with overcast weather. It was really, really, really tough to actually sight these guys. And that's all.
Ranty, I'm going to have to interrupt then.
Sure, go on.
Because if we're on a ball, all right, 12.5 feet from how far away?
Yeah, these guys were on a boat that was 12 feet in height, top to bottom, and they were 13.5 miles away.
It's not favourable match for a ball if he did spot them, is it?
I did spot them. Here's the thing, right? Here's the thing. This is them leaving the harbour, right? So I see these guys leaving the harbour. There's the 3 guys on the back of the boat. One of them's Rude Earther, and we've got obviously the captain. Now he's shooting off. He's firing off. He's trapping this guy. So I'm filming him. I'm just got to make sure I've got it on mute. Yeah. So I'm seeing these guys, and they say, "There's 3 of us on the back of the boat. Can you see us?" I said, "Yeah," because he's on the phone to me, and I'm like, "Yeah, I can see you guys. Yeah, not a problem." So I know I'm seeing these guys, and then in a minute they pass. From my perspective, if I've still got it on this particular video, they're sort of like there. So there's the end of Llandudno there, right? So from my perspective, I'm seeing these guys, and I say, "Right, yeah, you're just passing Llandudno now," and they go, "No, we've just come out of the estuary." So it's okay. Honestly, it was comedy gold. But you know, I want to try and be honest about how it actually went down, the mistakes that happened, so that if people do this again, they're not going to make the same mistakes, because it is just basic mistakes. You know, look how fast this boat's going. I mean, already he's coming to the side of Llandudno now. And there we go. So I've seen him pass Llandudno now, and I'm on the phone to him. "Yeah, you've just passed Llandudno." He's gone, "No." so anyway, I just thought I'd show that. I just thought I'd put that in because I thought it was quite amusing.
So did you say you were blaming Captain Birdseye for this?
Yeah, I've got to blame Captain Birdseye for this. I can't blame myself. Come on. Can't do that. Well, you're there.
No, it's a fair point, though, mate. Actually, the relative positions of landmarks.
Yes,
change.
That was it. Yeah. So from their perspective, as I say, from their perspective, they hadn't. They'd just left. From their perspective, they were here, right? But from my perspective, they just passed Llandudno, which is over here, because it's. And this is where the confusion started. So of course, you know, I'm spending all this time looking back for these guys afterwards, whilst they're happily trapping off to these turbines. And then once they go through these turbines, you know, I'll show you in a bit just how small the boat actually gets in comparison to the turbines in the foreground. Really tricky to find these guys. What else do we have? Right. So
there's a good example that parallax is relative to the observer.
Yeah, exactly. And it's also that personal dome. You know, think of your own personal dome. You know, I mean, this to them, they were where they were, and to me, I was looking at where it was just, you know, your own personal dome sort of thing. GPS and the phone. So, right, there was GPS on the boat. However, because my car broke down and I couldn't fit all the equipment that I've got in a suitcase, because I literally took a suitcase with me on the train, 4 stops, right, to get to this place, 4 changeovers from different trains. And I had to make that decision on the morning to actually just go ahead and go for it. 4 stops, suitcase full of equipment, didn't have any room for anything other than my cameras, and I wanted to put a laptop in, but I should have done really, because having GPS, I would have been able to locate them a lot quicker, right? Unfortunately, I didn't. And the phones were terrible. You know, I mean, we were losing contact with each other. You know, I couldn't contact them. They couldn't contact me. You know, it really was tricky. You know, going forward, maybe have some kind of walkie-talkies or something. Because obviously phones are unreliable. So, yeah, so the camera viewer, that fits in with that. So the camera that I'm filming through as well, the screen on it is only quite small. It's only like 3 inches by 2 inches. And I had the sun behind me. Well, the sun was behind me, even though the sun wasn't out, but it was still bright enough to cause a glare on the screen. So I was finding that I was having to hover over the viewfinder to try and keep the light out so I could try and see anything. And you're trying to view something on such a small screen, you can't pick out all the details. So again, it's another lesson that I learned. It was a mistake.
Are you showing off there? Are you telling me you can take those shots by looking at the screen as opposed to through the viewfinder?
Yeah.
You are showing off then. Yeah. That's a steady hand. That's a steady hand.
The measurements. So I think if Spursky decides to join, he's not joined yet, has he? I've sent him a link.
Yeah, I'm here.
Spurs, you are there, right? Excellent. Right, okay. So yeah, we did some measurements prior. So we set the tripod up. Can you tell the guys what height the tripod was that we measured?
At 4 foot.
Evening, Spurs.
Hey, Adam, you okay?
Yeah, evening, Spurs as well. Yeah, I mean,
yeah, that was 4 foot. That was.
Yeah. So the camera was sat on a 4 foot tripod. Yeah.
Tripod. Yeah.
Excellent. Right. And thanks for coming as well. I mean, you know, having you there was excellent.
Excellent. Yeah.
Rodney, can we I just need to check whether I'm about to blow a bit of smoke or not. So you say, I mean, I'm not talking about the 4 train stops. That's an indictment of British Rail. But why are you getting a train?
Well, my car blew up. I say blew up. The head gasket went last Friday on the way back from Scotland. So, cut a long story short, the garage got the car Saturday morning. And on Monday morning, they said to us that the car would be ready, hopefully on Tuesday. Because it wasn't the head gasket, they said. Even though the AA man that came to look at it said it's the head gasket. So anyway, so they said it was going to cost 250 quid or something for the water pump, something with a water pump and a piston and something else that had gone. Right, okay. So it's going to be ready by Tuesday. So I thought, right, okay, it's cutting it fine, but at least I'll be able to drive down. So waiting for, you know, tea time on Tuesday, phone them up and they say, we were just waiting on a part, and if it doesn't come in by such a time, we won't be able to fit it. So it looks like it's probably going to be on Wednesday morning. So right, okay, not a problem. So then I had a decision then. If I wait for the part to arrive and it comes before 9 o'clock and they fit it and fix it by 9 o'clock, I can drive down. And if they don't, then there's no way I'm going to get there. The trains won't make it. I won't be able to get there. So I thought, well, I'll have to try a train. I might as well just get on the train. And it was that decision that how I figured it out. And then I got a phone call at 12 o'clock from them saying to me, oh, by the way, the car, it won't be ready now till next week because the head gasket has blown. We've fixed all the other issues with it, but the head gasket's blown. So now it's going to need skimming, and we've got to send it away. Somebody else has got to come along and skim it, and then we're going to bring it back and test it. I'm like, ugh.
Yeah, I'm not a mechanic, but
close to £1,000 now.
I'm just checking the point, so I will blow a bit of smoke. Respect, mate. That is effort for not putting other people out, because I know, like I say, Spurs other people. Respect, fella.
Yeah, well, I didn't want to let anybody down. You know, I mean, it was one of them, and it's like we'd made plans. We'd been looking forward to this for such a long time. Probably about 3 weeks, I would say. A lot of planning, as far as I thought, a lot of planning went into it. Obviously, this list that I'm showing now pretty much shows that that went out the window, but it was definitely a learning experience. And yeah, so I just didn't want to let anybody down. So hopped on the train, and then I had to get a taxi back at night as well. I mean, it cost quite a lot of money all in all to do all that, but it's just the way things go in it. I mean, things happen in life, and you just got to deal with it. So, right, okay, so.
No, I'm not having that, mate. Some people go, oh, I can't, and then don't. So respect.
Yeah, cheers, mate. Cheers. Right, well, can't have flat water due to gravity, right? Well, you can't. That's a very simple statement of fact. You cannot have any flat water on the Sphere model. End of story. You just can't have it. It can't be flat ever. Correct, Adam?
Oh, if it's on a ball, then no, because by definition it is curved.
Well, it's all being pulled to the center of gravity. So you have the liquid water, and obviously it's all being pulled to the center of the Earth due to gravity, and it has to curve. It's just the way it is. It has to curve. You can't have flat water. So let's get that in right now. Obviously, the angular size limit I'll talk about in a minute, because that boat at 13.5 miles away, from an elevation of just 7 feet, is going to be pretty small. And the food. And I have to say, thank you very much to Rude Earther, who made us a lovely dinner, and thank you very much for that. So appreciate that. Right,
I like that, Ranty. I like that. I was thinking earlier what you were doing in terms of prepping next trip. Check the equipment, make sure I've not got Captain Birdseye, make sure I've got a GPS, other backups, other ways of communication, and then there's your snap. Got to make sure your snap's right. So, yeah, good amendment at the end. And if you were looked after,
yeah, we were. I have to say, really well looked after. So, massive thumbs up to Rude Earther. Right, let's show you some images. I'll show you the footage in a little bit, but I just want to show you some images to start with. And because I've titled this, can you guess what I've titled it, Adam? Because you gave me the hint for this.
It better be Panda Boat.
It is Panda Boat, mate. It's Panda Boat. So, come on, guys. Here we have Panda Boat, right? I love this boat. It as soon as I saw it on the video, it's like all the other boats, to be fair, in this video. They're all the same. They've all got this compression issue going on. And in this case, there's no difference between this and the other boats. They're all having this compression. And I'm going to show you and document this in a minute. And we are seeing all of the boat. This is the thing. And because we've got so many different boats passing forward and back, and there must have been on this particular day at least 8 or 10 different boats at different positions. They can't all have been looming, let's put it that way. But on this particular day, there just appeared to be hardly any, if no inferior mirage at all. There was just nothing. It was a very muggy, murky day, I have to say. But when you got the video back and I got a chance to look over some of this stuff, what we were actually seeing was just compression. No inferior mirage, but compression. And that goes hand in hand with my theory that when we see the inferior mirage, it's actually hiding the compression. So the compression is behind the inferior mirage. And the only time you ever get to see this compression issue is when there is no inferior mirage. So I've always thought that they go hand in hand. And I think these observations just kind of prove it today. It's really, really cool stuff. I'll get back to that image in a minute. But this boat that's in question is called the Iceni Conquest. And I've put the number of the video on, which is 8011 from the P1000. So I'll get rid of that. Get off of that. So the height of the boat is 10.3 meters. Sorry, 10 meters to the top, or 33 feet. That's how high it is from top to bottom, right? And what I've done is I've obviously turned this image backwards because I couldn't find a side-on image that matched. So this is the side-on image that I took off Google. I managed to switch it around so it matched up the same direction that this boat's going. And then I scaled it from the blue part that we're seeing to the blue, and the front of the boat to the front of the boat. And then I've got this same image and I've pasted it down here. So we know that the width is the same, but you can absolutely see the compression that's going on the left compared to the original image. So these two images are the ones we're going to concentrate on. And absolutely, you're seeing all of the boat. You're seeing all of the boat because it's panda colored. And you're absolutely right, Adam. Panda boat is probably going to be my new favorite image going forward, because it's better in so many ways than Shark Boat. Shark Boat was excellent, but this Panda boat is just beautiful. Look at that. Look at that compression.
It starts at the top of the antenna, and you can even see the relative compression there, but it's the way it's magnified as you go down the stripes. It's fantastic example.
I want to go further and say that, let's just say that when we put the curve calcs in, if we beg the question and go for the curve calcs, I'll just try and bring up a few of those. Make sure I got the ship IAS right for the particular one. So that was for the boat.
Just to check, Ranty, while you're talking numbers, the 10 meters, is that 10 meters to the roof of the top deck, or is that 10 meters to the top of the antenna? And
this is the vessel details for the Iceni Conquest. So it goes into all sorts of stuff. It's got its draft, it's 1.2 meters. The length overall is 21 meters. Beam 7 meters. Max draft in meters is 10 meters. And that is consistent because I actually measured the boat from the image. So I took this image and I measured it, or a different image, same boat though. And when I scaled 21 meters from front to back, and then measured the same in scale from top to bottom, it was 10. So essentially this is, I would have to say that whatever this is, this 10 meter here it's got to match up, because that's 21 meters and that is 10 meters when you scale it. So
it matches to the top of the mast.
Yeah, to the top of the mast is 10 meters when I scaled it. So there can be no doubt.
Well, that's even better then. Cool.
Right, let's see if I can find this boat again. So the Iceni Conquest. So here we go. This is the Iceni Conquest. This is its global position at 2 o'clock. So obviously over in the distance here, this is where we have around about here, we have the Douglas Complex. And this is the Iceni Conquest. And it's basically traveling from right to left. It stops here and it stays in this location for like 10 minutes. So if I go to 2 o'clock and 10 minutes. So if I there we go. So it's just basically just turned around. It's changed, turned around, and is starting to go in a different direction. So I've got that on film. So this is where this boat is at the time, and I can show you that how far away that would be on this. So that would be this particular. I'll just pop it in here actually, and we'll just get a distance on this. So this is how far this boat away was at this time. So from there to there, we're looking at 9.22 miles. So let's put some curve calcs in. Let's beg the question for that. So we're going to go 9.22 miles away. So using refraction and begging the question, we've got nearly 19 feet of missing, nearly 19 feet. And obviously just the geometric hidden is 24 feet, right? But let's beg the question. Let's give them 19 feet. And then we look back at the image, which is this one here. So we look back at the image and we know that it's only 33 feet to the very top up there, to the top of the antenna, which is right here. So let's just pop that in. So there's the top of the antenna right there. There's the bottom of the boat. And we know we're seeing all of this boat. Where's the 19 feet of hidden there? Using there, begging the question, ball mathematics. However, if you was to overlay this boat and do a blink test, so let's extend this line now and do a blink test. So essentially we're just going to extend this line and say the top of the boat is here. There's the antenna. There's the antenna at the bottom. So obviously they sort of line up a little bit out, not too much though. But look how much would be hidden if you did a blink test. Would that be close to 19 feet?
So do you think this applies for everything then, like buildings, the sun? I mean,
well, I think that normally what you would normally expect to see in this exact instance is an inferior mirage of the boat. 9 times out of 10 you would see an
I've never
inferior
looked
mirage.
at it like that before, like with the bottom compressing that much. We're seeing all of the bottom of the boat. It's not being hidden, you're saying, yeah?
Yes, yeah. It's not being hidden. You can see the colours because it's Panda boat.
Yeah,
that's what's really cool about this, is that we've got blue, white, blue, and you can so easily identify them. I mean, this is just like the Stena line on steroids.
What's good about the Panda boat, Spurs, look, if you look at it, is the rate or the level of compression that occurs as you approach the visual horizon. So because you've got the stripes, you can see that pretty much if you look at the first boat, the real unaffected.
Yeah, I can see it. Yeah. I've just never looked at it like that before. The bottom is just compressed. That's, they say, where's the bottom? It's not obstruction, it's compression. That's what we're looking at here, yeah?
Yeah. So you've got that it's compressed, but if you, like I say, if you look at the first white and the first black, the rate, and then the first black and the second black stripe, and then the first white and the second white stripe, you'll see that there's a different level of compression, and that basically as you approach that visual horizon, the compression rate increases. So the last millimeter is equivalent to a meter or 10 meter, 3 or 4 meters, a lot higher up. It's a really good example of how
this is a really good find. I was just about to say, this is a fantastic find. This is so I'm just thinking, do you think it's the same then for when they use the bottom of the building or the bottom of, I mean, can we apply this in?
I think you can, because essentially what you're saying is that if you've seen the Stena line stuff as well, if you let me just put a window in. So let's say we're looking at a building and that's a window, right? And then we've got another window on the next floor lower down, right? And then they do a blink test and they say, well, there's a few floors missing. But then what you're not taking into account is that if this compression is happening lower down, the window that's at the bottom is only this height now, which is half the height of the window at the top. So you're getting a lot more compression going into these very narrow bands at the perceived horizon.
Can you just show those bands, Ranty, with regards to the Panda. Just the white. The white's the best example.
Oh right, yeah. So yeah, I mean you can easily do it with the scale. Hang on, I don't want it on the line. I want it on a box. So let me just try and show you. So there's a box around the white, the white part of this boat over here, and then when you lower it onto the bottom part, it's twice the height. It's twice the height of the lower one, and it takes up all the hull. Yeah, exactly. So here we've got the white part of the boat at the top, and then when we lower it down to there, it's taking up the hull as well in this image for scale.
Okay, so let me just ask: if that boat were to move away from us, what do we suppose is happening?
Well, I do actually have another image of that I'm going to get to in a minute.
Okay.
And what's really interesting on this particular other image, I mean, these are just the stills of the same boat that I used. So here we have an image of that same boat, and it's turned around and it's going back from left to right now. But have you noticed, can you see you've got the blue line here just above the water, and then you've got this white trail that follows the boat. And what's really interesting and important about this is in the video, you see this wake behind it. You see the wake of the boat. So as the boat's moving, you're seeing the waves behind the boat, even though you aren't seeing the hull of the boat. So can you see how most of the blue's gone on this
So just
boat?
repeat that. You're seeing the waves. Say that again so it's clear.
Right. So we're seeing the boat. We're seeing all of the boat, even though we're not seeing the blue at the back end of the boat. We're seeing the blue at the front end of the boat. And at the back of the boat, the blue is just a sliver. It's not as crisp as this image. So on this image where you've got a nice thicker part here that's easily seen, in this particular case, it's almost gone completely. And this white that's here is the churned up water as the boat's moving through the water. So you're actually seeing the splash from the propellers. So you're actually seeing down to the bottom of the hull, even though you can't see it. And it's all compressed in this particular very, very narrow sliver here.
I think you need to qualify that, Shane, with an understanding of the choppiness.
Okay, well, you couldn't see the choppiness if you weren't seeing the boat. The choppiness would be beneath the boat. How do I say it like that? Does that sound better?
Yeah.
So here we have the boat. There's the chop. There's the chop from the waves as the water goes through it. And we're seeing the chop. So if we're seeing the chop, we're seeing the boat. Does that make sense?
Yeah.
Seeing the chop, seeing the boat. But even though we can't see it on this particular image, but you can still see the compression. So yeah, on this particular slide, I put this one in because just bear with me. Right, so I put this in because this boat has just passed not this turbine, but 2 turbines further to the left. So not that much further away, but due to perspective, it's like 2 turbines to the left. And what I've done is I've scaled the yellow part of the actual wind turbine to give you an idea of how small this boat was in the distance in comparison to this boat in the foreground. So we know that this boat in the foreground is 9.22 miles away. You would have to assume, using logic and reason, that this boat in the distance, which I have the video of, which travels from left to right and goes behind these wind turbines, has to be substantially further away. Obviously, it's probably going to be a good bit smaller as well. And it's my belief that we were seeing the boat that we hired on the day this. My belief that Rude Earth was on this boat. It looks like the boat. It moves as fast as the boat. It's about the right height that you would expect it to be at the distance involved using its GPS tracker. So the boat is about 12 foot in height. And I'll show you on Google Earth where the 2 of these would have been relative into each other. Can I prove it 100% that it is the boat that Rudy was on? No, I can't. However, there's enough information from what we've seen to make an educated guess. So this is the track of the boat that Rudy was on. Comes out here and it traverses across this location here. That's its exact path. And you can see it on, if I show you up on AIS tracker, which should be on this one. So this is the boat itself. It was called the Jensen. You can all guys go and check it yourself from yesterday. That was its position at 1409. This is the route that it took. It left, it went straight ahead, went through the turbines, passed in front of the Douglas complex, and then returned. So that's the route that it took. And I'll show you the video in a minute. So let's go back to that image. So here we have the 2 boats. So if this one was 12 foot tall, put a line in. 12 foot tall, and it's at 13.5 miles away. So angular size of the boat. This one's at 9.22 miles away. It's a little bit higher than that, actually. And there's the bottom of it. And it's 33 feet tall. It's pretty close. There's enough there to say that it's pretty close. And there really was no other boat in that location at this time that could possibly be this boat. So it's conjecture at the moment. However, it also goes to show that it must have been at least, this boat must have been at least 9.66 miles away. And I'll show you that on Google Earth. So let's get the direct line of sight through the Douglas complex, which is these red lines going through here. And the direct line of sight passes between this turbine and this turbine. So we're actually looking through these turbines right now. So if we're looking through the turbines and the boat goes behind both turbines, that has to place it at least in this position here, right? So let me just put a marker in there. I'm not going to say it was any further than that. So I'm just going to say that it must have put it at least in that position. And I've figured it out to about 9.66 miles. So let's just see. So yeah, 9.67, 9.66. We'll go for 9.66. I'm not going to argue over a point. So let's put that in. Go into Metabunk's curve calculator. Let's put 9.66 in. Refracted hidden 21 feet, and the geometric hidden 27 feet. And let's look at the image again, and let's just work it on. Let's just presume then that they're a very similar distance away to each other. So this is 9.22 miles. This is 9.66. How small is this boat in comparison to this? If this is 30 feet, this boat, let's say it's 12. Let's give it an arbitrary 12 feet and say it's 9.66 miles away, right? It's only 12 feet in elevation from top to bottom. Only 12 feet. And yet we're seeing all of it. And yet the curve calcs say, even uses refracted hidden, that almost 22 feet should have gone. So when we look back at the image, absolutely none of that boat should be seen. Let's put a line in. Let's put an arbitrary another 10 feet on top. That boat should have all been hidden, but we see it cresting the waves as it goes through the water. What do you think, guys?
I think the boat's half the size, or roughly. It's reflecting a very close approximation to that. What's interesting is that the back boat is a lot, whilst its height still is attaining a very similar angular size relative to the other boat's angular size. And there will be some slight variance in that based on their distance. What's interesting is you see what's left of the small boat. Pretty much all of the main body of the boat is compressed into very small proportion of it. And that's that kind of logic that asserts, for me, confirms what you're asserting. It's that's matching those, even that small level of detail confirms your assertion.
I'll show you some. Let me get some timestamps because I've got some timestamps on these. So let's just see if I've got it on. Saved it here. No, I know where I'll find it. 1 second. Right, so we need to look at the DSCN 801 at 2 minutes. Right, so let's get off of that. DSCN 80, what was it? 8011 at 2 minutes. I think it was, wasn't it? So here we have, well, there's boat number 1 for a start. There's the compressed boat from video. And did it say 2 minutes? What was that for? Let's just see. I think we see it moving through the wake. So this is it moving through the wake, and you can see the water being churned up at the back of it, proving that we're seeing the propeller blades of it. There we go. Look at that. You see how it's different to what's in front and how compressed it is. Let's get rid of that. What's this one? DSCN 801, right? Okay. 250. Oh, this is a good one. 8012 at 250. me skip through to that. So there we go. There's the boat. We're looking from the right to the left. So here we go. This is the small boat that goes behind that wind turbine. So it's gone behind the first turbine. It's now going to head past the second turbine. And there it goes in the distance. Now that boat is at least 9.66 miles away. There should be, was it over 20 feet of curvature or 19 feet of curvature? And we've already demonstrated how small that boat is by using logic and reason and scaling it to the other boat, the Iceni Conquest. There ain't no curvature, just compression.
So
it's going to be. Sorry, Adam, go ahead.
No, you go, bro.
No, I was going to say it's going to be a lot. It's going to be hard for you know, for them to accept. It's going to have to be a lot more research, which is what we're going to do. But they're probably going to want an equation for this compression. Obviously, they won't just accept this.
I'll give you an equation. I'll give it you. 8 inch per mile squared. That's the equation for compression. It seems to me like they've hijacked perspective.
Well, they're gonna want an equation. I mean, to fit with a model of some sort. Obviously, the models are pseudoscience, but I mean, nonetheless, they're still going to want this to you know, to be able to make equations with it. You see, does this compression happen everywhere? Is it consistent? How can we work with it? You know, that's so. We can't deny what we're seeing. We're seeing compression. We're seeing things being compressed. But again, I think they're going to want some kind of equation. What do you think, Adam?
I think they will use any semi-reasonable sounding request to try and obfuscate from denying what is plainly put in front of them. And whilst the future of calculating this kind of this discipline with regards to how refraction light and the rendered image occurs, to try and stick a formula on it with regards to, and there's many variables in this, you know, aperture size, lens size, there's lots of nuances that will affect what we're seeing. I think that would be a very weak sidestep and not actually dealing with the point of what Ranty's presenting there. Clearly, the most clear thing is we're not seeing an obstruction. We're seeing compression, and that compression appears to account for the whole of the image, and is decreasing at a rate which, well, the compression is increasing as you head towards the visual horizon, and there's a lot of data there that asks you to think about what's happening. It doesn't prove it. It doesn't provide a formula, but what it does do is demonstrate there's no obstruction, and that image clearly, using logic and reason, could not have been observed across a spherical surface.
Yeah, it's interesting. It's like it's a starting point for some, you know, for people to work with. Now, I mean, if it is compression, we should be able to demonstrate this, you know, time and time again, I think.
Well, yeah, I have demonstrated it several times in the past, but more often than not, we get an inferior mirage, and I fully expected these guys to go out and was hoping for an inferior mirage. I mentioned it many a time that this is what I expected to see, and I was hoping that we were going to be able to penetrate that inferior mirage with a whole bunch of stuff that I asked them to take on the boat, because I expected to get them to go through an inferior mirage. I didn't expect not to see an inferior mirage, but just compression. I mean, it's what I've expected. You know, what I've theorized as regards what happens is that when you're seeing this boat, generally you get an inferior mirage that comes down and it repeats the boat down, and it would also have the effect of lowering the horizon. So the sky above would be mirage down over the water, but in the atmosphere. And the same with the boat. So you'd see an inferior mirage underneath it, and that's where they would used to claim, you know, curvature. But the inferior mirage is where they always used to say that's where the bottom of the boat is. And I'm like, no, that's not the case. It doesn't happen like that. And the inferior mirage hides the compression. That's what I've always thought. So it goes hand in hand with this narrow viewing angle that you get this compression when you don't. You see the compression, a bit like Red Pill Philosophy in his video. You can actually see the compression on the buildings when he pans over to the left. This is just demonstrating that same effect yet again when we haven't got an inferior mirage. So I think they go hand in hand, definitely.
Do you have the reflection of the mirror at all? Did we see that?
Well, that's the thing. You see, on this video, when we saw that light, we were asking them at this exact time. It's a good job you mentioned this actually, because I'm just going to get onto this point. You see this light at the bottom that's reflecting here. Now I'm looking through a 2-inch by 3-inch viewfinder, and I have the glare of the sun behind me, and we're seeing this flash going on at the perceived horizon, and we're like, flash the mirror, and we're flashing the mirror, and I'm like, we can see it. So we put a video out called Success, and I'm actually recording Success on this P1000 footage. So towards the back end of this 6-minute video, you'll hear me doing the live stream at the same time, and they cross over. So I'm actually filming what I'm thinking right now is the reflection of the mirror from the guys on the boat. Turns out that yeah,
is that the Douglas platform behind you?
It is.
Yeah. So how far away is the Douglas platform, do you think, from the boat?
I think it's 15.5 miles away.
15.5 miles. And how far do you think the Douglas platform is above sea level on its plinth?
177 feet.
So probably higher than the mirror, the light on the boat.
Yeah. But it's being compressed
again. It looks level, doesn't it? It looks like it's on level with the base of the platform, 170 foot above.
But that isn't the mirror. It wasn't the mirror. I thought this was the mirror right now.
Right.
I'm like, yeah, we can see you. Flash that mirror. And they say, so he's going mental saying, I'm flashing the mirror, I'm flashing it. Because, you know, we're like, we see it, because we see this light at the bottom. So we're filming it. We get on, we do the video, release it called Success. Not realizing that we hadn't actually spotted them flashing the mirror. We do actually see them, I'm sure of it, in the video in the demonstration that I just showed with the boat going behind it. But because they're saying we're just passing in front of the Douglas complex now, and we're flashing the mirror, and this is when this boat passes through. So here we go. So I don't see this boat passing through in a minute on my screen. So when this boat goes now, I don't see this. I'm doing the live stream and I don't see this. So as far as I'm concerned, this is these guys flying by behind the turbines, and we're thinking we're looking at them here, but we weren't. In any case, again, it was just another, you know.
I was going to say that the light, that light is fixed and as well, it's not moving.
Yeah, but it does look like a mirror flash. You know, it looks like rectangle and flashing and.
I didn't say you weren't justified in getting excited.
But, you know, it's all about being transparent and honest. You know, I actually thought that was them guys. And if you actually look where the boat is now, so that boat's passing in front of it, look where that flash is happening in relation to the boat. Can you imagine if they were hanging a mirror off the side and flashing it? It would appear right in that exact location. And they're saying to it, we're just in front of the Douglas complex now, and then boom. There they go, passing in front of it. We caught that on this P1000 footage. Didn't catch it on the live stream, obviously, because we thought this was them. But I'm absolutely positive that that's those guys in the boat. And if it's not, it doesn't really matter. It's still a much smaller boat that's at least 9.66 miles away, and we're seeing essentially all of it. Completely, you can't have flat water. So I'll go back to my original image, which was this point here. That you cannot have this. You cannot have flat water due to gravity, right? You can't. It's impossible. So there's a lot of explaining for the globers to do right now. They're obviously going to go around and say that this is being refracted. However, I have an awful lot of video and I have an awful lot of other boats in their relative positions that are nearer and further away. Some of them much further away. And again, we're seeing them in their exact positions where they should be on the GPS. We don't see any loss of the hulls or anything like this. These were the two most easily identifiable, because the further away you go, these small boats become really hard to figure out what you're looking at. It's really difficult. I mean, look how murky the weather was. And that was due to the fact there was very little sunlight. On a bright day, it's quite feasible that we would have seen an awful lot more, but would the brightness have brought the inferior mirage? See, that's another thing to think about. Maybe it was because of these conditions that allowed us to see without an inferior mirage, you know? Just really, really, really cool. Anyway, I mean, a lot of work went into this, and I can't thank Rudy enough and all the guys that turned up to do this, because just for this little nugget here, this boat going behind this this wind turbine, this boat here, this is the nugget, goes behind the turbine. It has to put it at least 9.66 miles away, and there should be at least 20 feet of curve. And then when we measure it to the other known boat in the area, which is this one, we measure it to this boat here, which is being compressed as well, bearing in mind. So it should be much taller than that, but it isn't. It's still substantially bigger than this boat, and that's only 30 foot in elevation from top to bottom. So this is either a very small boat at 9.66 miles away, or it's Rudy's boat at 13.5 miles away that's just 12 foot in height. Which one is it? They can have the pick.
What do you think the cause of this compression is? Why is it happening?
Again, it's going to take more data to figure out, I think.
No, I know. I'm just thinking we could just think about what's going on, because I think they're going to want a lot more than just compression. I mean, I agree. This is what we see, but you know, that should really end the debate or the discussion.
Well, yeah. I mean, you can see the difference here. It's demonstrable.
It requires a recognition spur. A camera shot is not equivalent to a thermometer or a voltmeter. You're not going to get the same reading now. I'm talking outside of atmospheric conditions here. The camera itself, all the nuances of the camera will lend, just like your eye, my eye, will lend to a different visual resolution. I don't think we're necessarily talking about that. That's the sort of thing that you'll get difference. But what we're seeing here with what Rant is doing is demonstrating how all lenses work, how as you approach that visual horizon, as you view off to infinity, the compression occurs. I think if we can recognize that that is a reality, that'll be a great step. Unfortunately, I don't think it's something that the ballers will recognize because of the implications of it once they're recognized.
Right.
Yeah, just another thing that I want to show you this video here, because this was the video that I released called Success. I just mentioned before that I was filming that that footage as that boat traversed in front behind the turbines, actually whilst this live stream was running. So you can actually see where the height of the tripod is in relation to the water beneath. Now you can see that there's this we're on a step, so there we are on the step, and we have this little bit of rock, and then we've got a tiny bit of sand, probably about a foot of sand before the water actually laps up. If I play the video a tad, you'll see how these little tiny waves are just lapping up at the shoreline. Now, at the time on the video, I state that the camera tripod is set to 4 feet, and I roughly estimated that the height beneath the step down to the actual water was 3 feet. Now, I didn't think that was a problem until I got a message from Ruhif on Skype, who said to me, actually, I think that's more closer to 7 feet on top of the 4 feet tripod height. So I think that you are, you know, essentially 11 feet above actual sea level, right? Now, I took offense to that because, you know, I was there, Chemo was there, and you know, I'm not one for lying about this stuff. I'll be honest about pretty much everything that I can do. I mean, I can't be any more honest than saying that I'm giving it a wide 3 foot on top of the 4 foot. So I'm going to give myself a 7 foot elevation. So I said, right, no problem, no problem. So I got in touch with Rudy, who went down and he did a measurement for me. So here's the tape measure in the sand. This is the step that I had the camera tripod on here, and he's put the measurement right up so that you can see. Now then, a direct line of sight to the step puts the height of the in inches. Let's do the inches, shall we? Let's go. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 1 foot. So we need to knock a foot off. So the tape measure is 1 foot higher than the step, and then we need to go down and see at what measurement that's in the sand. So we've got 32 inch, 33, 34, 35, 36. That's 3 feet. 3 feet and a quarter. Let's say 3 1/4 feet. But we need to knock a foot off because obviously the height of this is too far high. So we're looking just over 2 feet. So when Ruhif got in touch with me and said that it was 7 feet, that's dishonest. You know, I've always tried to be honest with my elevations. So actually, I'm going to say it was 3 feet because this is essentially set to 3 feet, give or take, right down to there. So let's give them 3 feet above actual sea level. Let's give them 4 feet on the tripod. And let's say I was 7 feet above sea level, even though we were lower than that. And this clearly shows this, right? And if you look at the Metabunk calculator that I've used and plugged in, you can see that the viewer height has always been set to 7 feet. I've never changed that. It's been set to 7 feet, right? I could have gone worse and said, actually, it was only 2 feet above sea level, but we're going to go and say it was 7. You know, 4 plus 2 would have been 6, so I would have knocked a foot off. But, you know, I was honest when saying I'm 3 feet higher than that, and then Ruhif really kind of wound me up. So a massive thanks to Rude Earther for going back down and taking that image as well, because it was really good in clarifying this point and rubbing it in his face. What do you say to that, Adam? These ballers, they're always the same, aren't they?
It's sad that you went from, I mean, you've demonstrated there's always a margin of error and stuff, and you can question it, but what did he say? 7 foot in total?
Yeah, no, he said 7 feet. Oh. From the sand down here to the step looked more like 7 feet rather than 3 feet, right? And I said I was being generous when I said 3 feet. It was probably closer to 2, but I have someone going back to measure it today, and he went back, he measured it, he sent me the image. It proves it's closer to 2, but let's say 3, and it's nowhere near 7.
Says a lot about the way they behave, their judgment, perhaps even.
Yeah, I mean, that's the thing. It's like they can't scale. I mean, I was there with Chemo. Chemo knows. He was, you know, he saw it.
Well, I bet Ruif's got a 6-inch penis, but you got to remember you got to knock a third off.
Yeah, 2 inch. 2 inch off.
Maths,
2 inch off. No,
I'm not that insulted. Yeah, not a couple of inch off there.
So I've got a whole bunch of this stuff that I need to go through. This is just a couple of Panda boat was just easy to actually work with, because it was an easy boat to find and definitively prove which boat it was. So let's just bear in mind that if we blink test that boat, that would match the curve calcs. So if we scale it from left to right, like we've done here, and we blink test it, so let's go, scale it left to right, so it's the same width left to right, and then we blink test it, this would be the hidden down here. So put the line in. So that would be the hidden, and that would match the curve calcs. Go figure. That is where the curve calcs would say that the missing would be. So if you blink test, put this boat over this, scaled it left to right, and then blink tested it, and let's suppose this was all the same color instead of it being panda colored. So you can't, you know, you can obviously see the different elements of each part of the boat. So if it was like just a normal tanker, let's say, that was just a black tanker boat, and they blink tested it, they would say, oh, look how much is missing. Yeah, without taking into account this compression that goes on.
I think it's what those pictures yielded. It's the sort of stuff that is worthy of proper further investigation, starting to be able to, like with some of the stuff that Zach did in the warehouse tests, you know, starting to really start to analyze the rate of compression and what that picture shows, and so clearly is, to me anyway, you know, what is happening, how the rate of compression increases as you approach that visual horizon. It's a great shot, mate. A great illustration.
Let's see who's in chat. Let's give a few shout outs to anybody that's decided to show up. Oh, we got 100 people watching. That's cool. Right. Wow. Julie Bennett, nice to see you in. Flat Earth New Zealand. I don't know where this is going to end up, to be fair, because if you don't follow this chat, you know, it sort of like scrolls down for ages. So let's see who's in right now. Bruno, nice to see you in. I'm probably miles behind on the chat. Ian Adams, nice to see you in as well. Right, so I hope you've appreciated that, guys. I put a lot of effort into that, and Rude Earther was really, really top drawer for everything that he did. But even going back today, I mean, can't ask for any more. So if anyone's got a link to his channel right now, pop it in and give him a sub if you can, because he deserves it. And Spurs Chemo as well. I mean, fantastic. You came down as well. And the day wouldn't have been the same had you not been there. Let's put it that way.
Did you bring sandwiches, Spurs?
I
I'll be a no.
guess it was a no. Spurs didn't
Did you not bring sandwiches?
I don't think so. So what do we learn? So yeah, so weather conditions, always check them, make sure it's sunny and bright out. Try to do it in when it's not quite so windy. If you can avoid going in the wind, great. If not, perhaps take a wind break.
Here, Ranty, on that, right? How did your moon philosophy turn out? You know, well, certain days after the full moon is the best time for clarity.
Clarity-wise, well, what date are we on now? We're on the 28th of March. Unfortunately, we couldn't do it on the day that I had planned. So it's after the moon phase, but a couple of days after the moon was really good. So a couple of days.
It weren't far after, was it? That's what I'm thinking. It weren't far after the full moon, was it? That was only last week, the full moon.
Yeah, it seems that in the build up to the full moon. So once it's gone, you know, in the last 10 days before the full moon or so, the weather seems to turn. You know, it gets really dirty atmospherics to try and look through. It's not very clear at all. So as much as I'm crabbing the weather on this day with the boat, you can see how milky the atmosphere was behind. However, the air clarity must have been pretty good to just get this anyway, and to see even the Douglas complex in the way that we're seeing it. So I'm kind of crabbing it because I really wanted to do it 2 days after the full moon. But how can you crab stuff like this, which just shows probably something better in every respect, because it follows up on the direction that we've been going with optics and the angular resolution and how your eye works, how the camera works, how it's going to compress things in a very, very small band. And that would explain an awful lot when you go to distances of 30 miles away, because the camera just can't pick out all the details because everything is trying to be crammed into so few pixels. You've only got so many few. You've only got, say, 10 pixels to try and pick out 20 feet of structure. So you're going to lose a lot of detail in that.
I agree.
Right. So anyway, so yeah, the captain. Make sure you don't get a globe Earth captain again if you ever do this. Make sure he's on board with everything you want to do. Make sure he knows exactly where you're going to go, exactly what you're paying him to do, and you know, if he's got any queries prior to that, like let's say that he thinks that the location is too dangerous to go to, you know, let him tell you all about that first, because essentially he wasn't very good. Equipment, yeah, and the GPS, the phone, make sure you've got some kind of backup. So if you're going to take a mobile phone, maybe consider taking walkie-talkies instead, or some other kind of communication, something that doesn't rely on a phone, because it was very intermittent. Camera viewer, try not to see through the P1000's camera viewer, because it's so small, so tiny, and if you're filming in 4K, you've got a lot of detail there, and you've got such a small screen. It seems like a complete waste if you're going to be doing something like this. At least take a laptop so that you can connect it up and you can look through the laptop, so you've got a much wider you know, field of view, so that you can see what you're looking at. Always do your measurements. Always remember you can't have flat water. There is an angular size limit, so at some point, even that boat that we were looking at over here, this boat here, at some point, even this boat would just appear as a smudge on the horizon. You can't see forever. It will get too small to see eventually. Eventually, that will become 1 pixel, and that 1 pixel, you can't identify it. And then when it goes further away, it won't even be there, because it will be less than a pixel. Something else will have taken its place. So the 2 pixel fly that's next to it would obviously look bigger than the no pixel next to it. So you wouldn't see it. Nothing would be seen of that boat at some point. Its angular size would be too small. And always make sure you get food. And if you don't get food, always make sure you got a good host that can give you a nice Sunday dinner, even though it wasn't Sunday. But give you a nice Sunday dinner. It helped for the journey home, let's put it that way.
Yeah, I'm snuffling into my tea now, right, Randy? Top tip, mate.
Right, guys. So yeah, I'm just going to knock it on the head right now. I think I've said everything I need to say on these couple of videos. I have a lot more data to go through, so I'm sure that this is basically just the very start of the analysis of this. But yeah, it's been pretty epic. Just this alone, it was worth it just for this. You know, most of that boat should have been gone. And the last point that I want to say is this boat that passed through the screen. I might play the video again in a second. This boat absolutely should not have been seen at all. This is a complete illusion. It isn't there. It's a hologram. You're not really seeing it. Even though the camera saw it, even though I'm playing this video for you right now, you didn't actually see it, because it's not really there. It's behind Earth curve, and it's being loomed up beyond the curvature of the Earth and into the line of sight of the camera. Here it goes. Everybody ready? Watch this boat, because it isn't really there. Whee! Fake boat.
Can't see it.
Imaginary boat. It's not there. Don't look at it. It's not there. It's an illusion. There we go. Right, guys. Thanks for stopping by. I do appreciate everyone coming.
No, I think you get yourself off, mate.
Great
get
show,
some
man.
more analysis done.
Great work.
Are you joining us tomorrow night? Hopefully.
I will join you tomorrow night. Yeah.
Yeah, wicked. So I look forward to the next bit once you've had a more chew. Spurs, mate, wicked. I bet that was wicked fun, pal.
Yeah, it was great. It was a fantastic experience. The guys did really well, actually. Did good. Great host, as like Ranty says. Many thanks for the day, and yeah, hopefully we'll probably do it again soon.
Well, that's the thing, you see. Rude has also said that he does want to do this again. So hopefully it's not going to be the last one. It's probably going to be the first of many. So fingers crossed. He'll also be coming to the Scotland one. So when we go to Loch Ness, I'm hoping that he's going to come to the Scotland one, because he just messaged me before actually and said, actually, that's Easter weekend. I don't know if I can do it, but let's just hope that he can. And if he can, all good. If not, I've actually been in touch with a few other people. John Smith from the Globe Light Tour, he's interested in participating in the Scotland test along Loch Ness. I've also got a couple of other people that have messaged me privately that want to take part in that too. So it shouldn't be a loss either way. And Spurs, you thought about coming up as well if you could make it?
Yeah. I'll definitely, if it's possible, yeah, I'd like to be part of that too.
Excellent. Right. Well, whichever, if whoever we can get, and Adam, if you want to come, you're more than welcome as well, mate. Everybody's welcome. I'll put full links to everything probably a week or so before we actually do it, detailing all the details, and also the fact that I've done it this time and learnt from all my mistakes means that next time we shouldn't make as many.
Bring sandwiches.
And bring sandwiches, yeah.
Cheers, pal.
Right. Thanks, everybody. Thanks for stopping by. And you're going to have to find somewhere else to go and chat now, because we're all done here. See you again soon.